So let's take a look at inequalities in section 1.6 here. So when we're solving these inequalities, we're going to use a lot of the same methods that we did for equations, but with some slight modifications. So the first thing that we'll be able to do is we will be able to simplify expressions on either side of the inequality, just like we did with equations. We can add or subtract the same expression on both sides of the inequality, just like with equations. And we can multiply or divide both sides of the inequality by the same positive quantity, like we did with equations. But the big difference here is that if we want to multiply or divide both sides of the inequality by the same negative quantity, we will have to reverse the direction of the inequality in that case. Now this should make sense because consider we talk about 2 less than 5. If we multiply both sides by -1, then we'd be comparing -2 and -5. But -2 is not less than -5. -2 is greater than -5, and hence we had to switch the direction of the inequality. All right, that's because of how things on the other side of 0, on the negative side of 0, really go the other way. So now let's do this in an example. So we're going to start with some linear inequalities. So if we want to solve 3x plus 11 is less than 5, then just like with an equation, we're going to subtract 11 from both sides, giving us 3x less than -6. And now we'll go ahead and divide both sides by 3, positive 3. Since we divided by a positive number, we don't have to switch the sign of the inequality, and we get x less than -2. All right, so we did a lot of the same things in isolating x that we would do with a linear equation. Now notice that our solution now is a whole range of values, x less than -2. So any x value less than -2 will work. So we want to think about a good way of representing our solutions because they're now infinitely many solutions, and we have to show that. All right, so what we have there is basically what I would think of as inequality notation. And that's one way we could express the solution as x less than -2. Yet another way is interval notation. So the interval associated with x less than -2 would be from -infinity to -2 open. And yet another way we could show this is using a number line graph. So I'll call that graphical notation. All right, so in this case, I might just put that graph there. And let's say we have -3, -2, -1, 0. And so we'd be saying open at -2 and everything behind. Or if you prefer the other notation, parenthesis and everything behind. So there would be 3 ways of representing our solution. Now, ordinarily we don't have to give all 3 ways. I'm going to give all 3 ways each time to keep us flexible with the different notation. All right, so let's try solving 6 minus x greater than or equal to 2x plus 9. Again, I'm just going to try and isolate x. So I'm going to subtract 2x from both sides in order to get the x's to the left. And then I'm going to, at the same time, subtract 6 from both sides to get the numbers to the right. So when I take the -x from the left and I subtract 2x, I get -3x. That's -x minus 2x. And that would be greater than or equal to, now subtracting 6 from both sides would leave me with 3 on the right. All right, so now I'm going to divide both sides by -3. Okay, now I need to take note. I divided both sides by a negative number, so I'm going to have to switch the inequality. So this greater than or equal to becomes less than or equal to, so I get x less than or equal to -1. So again, I'll go and represent my solutions. So my inequality notation would be x less than or equal to -1. My interval notation would be -infinity to -1, including -1, so closed on -1 because of the less than or equals to. And then as a graph, we would have, basically we would have, let's do -2, -1, 0. We would have -1 including, so closed, and everything behind it, or using brackets and back. Okay, so our next example is 3x plus 5 less than 5x minus 7. Once again, I will isolate the x value on the left and put the numbers to the right. So when I do the 3x minus 5x, I get minus 2x on the left. That's less than, when I subtract 5 from both sides, -7 minus 5 is -12. Divide by -2, divided by a negative, so we switch. Greater than, so I get x greater than 6. All right, so we'll make our solutions in our different notation. So our inequality is just what we have there, as x greater than 6. Our interval notation would be starting at 6, open, not including it, all the way to infinity. And our graph notation would show the number line, 5, 6, 7. So starting at 6, open, and forward to infinity. Okay, now with this inequality, we actually see we have a compound inequality here. We have two different inequalities, so we're saying that -2 has to be less than 8 minus 2x, and 8 minus 2x has to be less than -1. So we actually have two problems in one here. So the way I'm going to do it is I'm actually going to split these into two separate problems and then put them together at the end. So I'm going to say -2 has to be less than 8 minus 2x, and 8 minus 2x has to be less than or equal to -1. So solving these each individually, just like we did with the problems before, if I add 2x to both sides and then add 2 to each side, I get 2x less than 10. Divide both sides by +2, so x less than 5. Over here, I have leave the -2x on the left. I'll subtract 8 from the both sides, so on the right we get -1 minus 8 is -9. Divide by -2 on both sides, switch, because I divided by a negative, x greater than or equal to 9/2. So I need both of these, right? So when I go and give my solutions to this problem, I have to realize that I need to put these together. So in inequality notation, let's take a look. So basically we usually write our inequalities from smallest to biggest. So we're saying that x is less than 5 and x is greater than or equal to 9/2. So 9/2 is the smallest thing. So 9/2, and then reading this one backwards, 9/2 is less than or equal to x. And then back over here, x is less than 5, so we get something like that. 9/2 less than or equal to x less than 5. In interval notation, that would be 9/2 including 9/2 to 5 open. And then on a graph, a number line graph, we would see, so 9/2 is 4.5. So let's take a look at 4, 5, 6. So here's 4.5, 9/2. There's 5. So closed because we're including 9/2. Open at 5, everything in between, or in other words, bracket to parenthesis. Okay, so those were linear inequalities.